Okay, hello peeps, welcome back to another video on the mancubs channel. Today we're going to be doing another question for the GCSE Excel Maths Paper 1 Higher. That was today, a few hours ago. So let's get cracking. These are all the hard questions. If you want to see the rest of them, they will be in the end card, or they will be in the pinned comment, or in the description. It will say on screen right now where it is. So let's get straight into working out this problem. A circle we are given has a centre at 0, 0, the origin, which has two intersection points with line L. We've got 2 points, point P, which is the coordinates 5, 10, and point Q, which has the x-coordinate of -2. So we don't know what the y-coordinate is. Given that line L has a positive gradient and L crosses the y-axis at 0, k, work out the value of k. So this was the last right at the end question on that paper. I actually found it quite a nice question just to finish off with. Some of the previous questions, like if you haven't watched it already, check out the cuboid video that I found challenging. But let's get into this one. So I'm going to draw a diagram, because if you didn't draw a diagram for this question, you are a maniac. Okay, so we've got our circle, and we don't know what the equation is, but we know that it's got 2 points. We've got point P, which is about 5, 10. I'm going to say there. P, which is 5, 10. And we've also got Q, which is -2, but we don't know. -2 is here, but we don't know if it's going to be up here or down here. But we do know. Why? Because we know that the line L passes through point P and point Q, but we know also that line L has a positive, if it wants to let me highlight, has a positive gradient, which means that it has to be the one that is down at the bottom, like there. So if I draw line L coming through like there, that is our line L. And also, L crosses the y-axis. I forgot to label these coordinate axes. It has a y-axis. It crosses it at 0k, which is going to be here. 0k. And we need to work out the value of k. So, first of all, how are we going to... Let's sort of write out a plan of action. I did this a lot in the hard GCSE Maths question series, if you want to see that. Also in the... wherever. Maybe in the up right-hand corner this time. So, first of all, what should we work out? We need to work out the equation of the circle. Right? So if we work out the equation of the circle, then we can work out the equation of the line, right? Because this point here, the one that I'm just colouring in blue right now, will be matched with both, and we can figure out the coordinates of it. I'm actually just going to write here -2 something, like that. Once we've got the equation of the circle, what we're going to be working out is the coordinates of Q. I should probably have labelled it Q, shouldn't I? Q, there we go. And once we work that out, we can find the equation of line L, and then find, all we're finding for K is literally the y-intercept, so find the y-intercept. So let's look at step number 1 first, find the equation of the circle. Now I did this one way, and someone I know, a friend, also did it a different way. Shout out to them if you are watching. And I'm going to show you both ways. So the way that I did it in the exam, I made, let me just take this out, I made a triangle. So we've got here and there and there. We've got a triangle because this is point P and this is the origin, and we know that this is 5, 10, right? So we know that this is 5 across, 10, and to find the equation of the circle we need to find the radius, and this line here is the radius. So we can just use Pythagoras to work that out because this is a right angle triangle. So we're going to do a squared plus b squared equals c squared, and we've got 5 squared plus 10 squared equals c squared. So c squared is going to equal 125, and c equals 5√5 if you just simplify that a bit. So we know what the radius is, and let's just write out the equation of the circle because this is going to be very important. So it's going to be x squared plus y squared equals, and then our radius squared, which we've already got using Pythagoras, which is 125. Now the way that my friend did it, it's actually basically the same way using Pythagoras, but it makes a lot more sense. We know that this point P is on the circle, so we can just substitute in the values. So that's kind of what we did with Pythagoras, but it's a bit more intuitive, I think, his method. So literally all we just did is 5 squared plus 10 squared, substitute it in equals r squared, and then got the same value for r, which is the same method, but in a different way, which I really, really like. So now that we've got the equation of the circle, now we can work out the intersection point, or point Q rather. We don't need to deal with the line L at this point, because this point is also on the circle, so we can just substitute in our value of minus 2 in x to get a value for y. So, should we do that right now? We've got minus 2 squared plus y squared equals 125, and then y squared plus 4, because minus 2 squared is 4 equals 125. If we subtract 4 from both sides, we get y squared equals 121, and then y equals plus or minus 11. But we already know that it's only going to be minus 11, because we know that the coordinates for Q have to be in this quadrant, if you can see, in this quadrant here, right? Because this has to have a positive gradient. So we know what the coordinates of Q is now. We know that it's going to be minus 2 and minus 11. So now that we know 2 points on a straight line, we can just work out what the equation is, can't we? So I'm actually going to draw that over here. We've got another triangle. I think the triangle method is just the easiest way to visualize it. Over here we've got minus 2, minus 11, and over here we've got 5, 10. So to get from minus 2 to 11, how many across do we go? We go across 7. And to go from minus 11 to positive 10, we go up 21. So the gradient is going to be the change in y over the change in x, which we have seen. We go 21 up and 7 across, and that means our gradient is going to equal 3. So now that we know what the gradient is and we've got points on our graph, we can work out the y-intercept. So let me just do that over here. It's getting a little bit messy, but we know the equation is y equals 3x plus c. Let's take 5, 10 for example. Let's just substitute that in. So 10 equals 3 lots of 5 plus c. So c equals 10 minus 15. If we take that 15 and subtract it from 10, and then we get c equals minus 5, and c is equal to k. That means k equals minus 5, and that is our final answer for this question, which is really, really nice, isn't it? I actually really like this question in the exam. I didn't like the this one, the cuboid one. I liked the other two, but I didn't like this one so much. But that is pretty much it for this video. If you want to see all the other questions that I've just quickly shown you, the link is in the end card. Some of them are in the end card, and then some of them are in the pinned comment. And that is it for this little breakdown on some hard GCSE Maths questions of this year. I hope you did as well as you could in the exam. I know it was very hard for a lot of people. I found it quite challenging when in the exam hall as well, especially with the stress. Like, oh my gosh, it's so stressful. But I hope that everyone found it good, and good luck for the rest of your exams. The next maths paper is on the 3rd of June, so probably some more maths content coming then, but if not, I will see you in the next video, previous video, or whenever. Thanks for watching. Like, comment, subscribe, share, all that good stuff, and I'll see you next time. Goodbye.